The universe never rests. Although at first glance it may seem motionless, the truth is that it is in constant turmoil, filled with forces silently clashing against one another. In 1994, humanity witnessed one of those episodes that mark a before and after. Jupiter was struck by a comet in a sequence of brutal collisions that left scars larger than Earth itself. For several days, the giant planet was hit again and again, exactly 21 times. The protagonist of this story was the comet Shoemaker-Levy 9, and with its destruction, it left us with an unforgettable lesson. The cosmos is not a peaceful place, and perhaps unknowingly, Jupiter acted as a protective shield for our world. A year earlier, in 1993, the discovery took place. Caroline and Eugene Shoemaker, along with David Levy, identified a celestial object that did not behave like the others. It did not orbit the Sun, but had instead fallen under Jupiter's gravitational dominance decades before, becoming a forced guest. Its shape betrayed a violent past, fragmented, elongated, as if it had been torn apart by invisible hands. That comet was named Shoemaker-Levy 9, and calculations soon revealed its destiny. In 1992, it had passed too close to the planet, crossing an invisible threshold known as the Roche limit, a point of no return that condemned it to crash against the giant. Picture the scene: a cosmic traveler ventures too near a giant. The gravity of that colossal planet does not pull evenly. It tugs brutally on the side closest to it, while the far side struggles to hold on. Once the invisible boundary known as the Roche limit is crossed, the difference is so extreme that the object shatters like a glass toy. That is what happened to Comet Shoemaker-Levy 9. It disintegrated into a chain of at least 21 fragments, a dark string of pearls doomed to an inevitable fate, returning in pieces against the very planet that had destroyed it. The news spread through the scientific world like lightning. Never before had we had the chance to predict a planetary impact and watch it unfold live. Suddenly, every telescope on Earth pointed to the same spot, from ground observatories to the newly repaired Hubble and even the Galileo probe, en route to Jupiter, prepared to witness the spectacle. The mystery was set. Would the fragments vanish like smoke in Jupiter's atmosphere, or would they leave behind unforgettable scars? The answer came between July 16th and July 22nd, 1994, when the bombardment began. One after another, the fragments plummeted into Jupiter's southern hemisphere at over 216,000 kilometers per hour, nearly 60 kilometers per second. Each collision was a cataclysm. The atmosphere heated to 30,000 degrees Celsius, 5 times hotter than the surface of the Sun. Columns of fire, gas, and debris rose as high as 3,000 kilometers, defying the planet's immense gravity. The climax arrived on July 18th with the impact of Fragment G, a block of ice and rock 2 kilometers in diameter. The explosion was so intense that it overwhelmed detectors at several observatories. To put it into perspective, it released an energy equivalent to 6 million megatons of TNT, about 100 times more than Earth's entire nuclear arsenal detonated at once in a single location. What it left behind was a dark scar 8,000 kilometers wide, surrounded by a halo stretching 25,000 kilometers. For months, Jupiter bore black spots so enormous they dwarfed Earth itself and even overshadowed the famous Great Red Spot. But beyond the visual spectacle, it was a gift for science. The fragments acted as natural probes, piercing the upper clouds and allowing astronomers to study layers of Jupiter never seen before. Thanks to spectroscopy, rare molecules such as diatomic sulfur were discovered, along with metals like iron and magnesium, vaporized remnants of the comet itself. These elements served as tracers, revealing the presence of stratospheric winds moving at over 1,000 kilometers per hour. Water was also detected, though in smaller amounts than expected, forcing scientists to rethink models of the gas giant's atmosphere. That summer of 1994 left us an unforgettable lesson. The cosmos is not a peaceful place. It is a stage of titanic forces, where a giant planet can act both as executioner and as shield. That day, Jupiter not only showed us its most violent face, It also reminded us that, in some way, it remains our silent guardian at the edge of the solar system. The collision released an almost unimaginable amount of energy, millions of megatons of TNT exploding simultaneously. Yet Jupiter barely flinched. Lacking a solid surface, all that force sank into its gaseous layers, dissipating as if a stone had been thrown into an endless ocean. The scars we observed from Earth seemed indelible, but they were merely stirred clouds, temporary wounds on the giant's skin. For Jupiter, it was a mere scratch, but for Earth, it would have meant the end. A single fragment, like the famous G, would have been enough to trigger a global cataclysm. Had it fallen on our planet, we would be talking about a mass extinction on the same scale that wiped out the dinosaurs. That was the revelation of the summer of 1994. Jupiter is not just a distant colossus, it is our gravitational shield, the sentinel that deflects or swallows wandering bodies that might otherwise collide with us. Shoemaker-Levy 9 didn't just strike Jupiter, it reminded us that it could have struck Earth. But the story is not so simple. Jupiter, that guardian who seems to watch over us, also plays a darker role. Between Mars and it lies the asteroid belt, within which are empty regions called Kirkwood gaps. These gaps are not empty by chance. There, the giant's gravity disrupts asteroid orbits, flinging them out of place. Some of these expelled objects end up traveling into the inner solar system, sometimes on a direct course toward our world. It is a guardian, yes, but also a potential executioner. It deflects long-period comets that could annihilate us, but at the same time it can hurl asteroids at us as if they were projectiles. Its influence is ambivalent, powerful, and ultimately unavoidable. And if we go even further back in time, its role becomes even more crucial. According to the Grand Tack hypothesis, in the early days of the solar system, Jupiter was not always where we see it today. It moved dangerously inward, dragging material along and altering the orbits of planets and asteroids before retreating to its current position. That titanic movement shaped the fate of the solar system, and with it the possibility for life to flourish on Earth. Jupiter is pure paradox, protector and threat, guardian and destroyer. Without it, we might not exist. But thanks to it, we also know that our safety in the cosmos is never absolute. In its early journey, Jupiter was not just a wandering giant, it was also an architect. With its colossal gravity, it acted like a cosmic vacuum, sweeping away gas and debris from the region where Earth would later form. That cleaning act was decisive. Because of it, our planet did not accumulate enough mass to become a hostile, uninhabitable super-Earth. In other words, Jupiter does more than protect us. It helped create the conditions necessary for our existence. The impact of Shoemaker-Levy 9 may have seemed like an isolated astronomical event, but in reality it was a direct warning. When we talk about the day Jupiter saved us, we are not only referring to it capturing a comet that might have taken a different path. We are referring to the awakening it triggered in humanity. Until 1994, planetary defense sounded more like science fiction than real science. But witnessing the fury of the cosmos live taught us something fundamental. The collisions that wiped out the dinosaurs are not just a memory of the past, they remain a latent threat. That July marked the birth of a new era of awareness. Space agencies around the world began investing in the search, tracking, and cataloging of potentially hazardous objects. We finally understood that our destiny is not written only on Earth, but also up there, among the stars. Today, we are the first species, at least in this solar system, capable of altering the course of celestial destiny. And that idea ceased to be a dream in 2022, when the DART mission successfully deflected an asteroid for the first time. We demonstrated that we can not only anticipate danger, but also have the will and technology to confront it. The knowledge we are building will be a legacy for those who come after us. And there should be no doubt, one day all this effort will be what makes the difference between extinction and survival. And that concludes our journey through this interstellar mystery. If you were fascinated by this case as much as we were, don't forget to like and subscribe so you don't miss any updates. See you in the next video, if the universe allows it.